Here we have another limits at infinity example problem. And for our example problem, we want to evaluate the limit as x approaches infinity of our function. And so this function looks a little bit different than previous ones we've done. It looks a little bit more difficult, but if we follow the same steps that we've been doing, it'll be just as easy as the other ones. So the first step is we want to factor out the largest exponent term from our denominator. So we can go ahead and do that. And so we'll have x to the fourth factored out from our denominator. And that will be within our square root term. So you can see that our square root doesn't change yet. It's going to be evaluated over this entire term. All we've done is factored out this x to the fourth term from the denominator. The next step is we can go ahead and apply the square root to x to the fourth. So we'll do that here. And we can go ahead and also notice that we can factor out an x squared because ultimately our goal is we want to cancel out these x terms from the numerator as well as the denominator. So we can go ahead and do that to our numerator and denominator. And so what we're left with is our simplified function. And so the only thing that is different than what we've done in previous videos is we still have a square root term, but that will show that it's not going to change anything when we evaluate the limit. So we'll go ahead and evaluate the limit as x approaches infinity. And like before, the first and second terms can be simplified as 0, and then we'll keep our -4. And then we can evaluate the limit within the square root, same as what we've always done. And so this first term as well as the second term will go to 0. And for the third term, it will just be 7. So we'll have the square root of 7 for our denominator. And for our solution, it'll be -4 over the square root of 7.